My name is Cecilia Dang. I'm a software engineer on the AWS Lambda team. And I'm here today to talk about building high-throughput serverless data processing pipelines. And those are a lot of words, and I know they're like all strung together, and it's kind of buzzy, and it might not be clear what that is about. But I will definitely clarify what it all means and go into it. I kind of wanted to start off with a show of hands. Who's already using Kinesis with Lambda, or sort of, OK, awesome. I kind of wanted to gauge sort of if you already like knew your use cases and why you wanted to use streams. But I will talk a little bit about like why you would use streams and sort of common architectures that we see as well. So a little bit about me. I'm from Canada. I went to UBC. I started off at EA. And now I'm on AWS Lambda for the past 3.5 years. And the goal, as I mentioned, is for high-throughput, serverless, real-time pipelines. So what does that really mean? High-throughput. So it's a pretty nebulous term, but generally we consider processing anything in the gigabytes per second as high-throughput. Many AWS services have limits where you can tune and options to scale higher, but sort of this is what we're targeting here. Serverless. Here, it means no service to manage, but here we really want to talk about serverless compute. So being able to sort of abstract away anything besides just having the actual logic of your code running. And then for pipelines, this kind of implies sequence and order. So this is kind of how time works, or at least how we observe it. So we'll go into the time definition. But here, we're going to talk about sort of the real-time constraints that we live in and why streams is really good for that. So what to expect? Well, why streams? Why are you using streams? What are your use cases? And what is it really good for? Most of this talk is going to talk about streaming solutions for data processing needs, so we'll go over the benefits of that for sure. And then we'll talk about what Lambda is. I'll do this really quick. It seems most people in the room is pretty familiar with it. And then we'll dive into what Kinesis is, how they really do the streaming side of things, and a little bit on what they deliver on that end. And then challenges on processing from streams in general, and basically how you don't need to worry about it with a lot of the AWS managed services that you have to offer, and then particularly dive into how Lambda processes streams. That's the team that I work on, and in particular I work on the event sourcing team, so I can dive into that. And then we'll go into sort of some more example use cases of all these different offerings and how you can sort of hook them up together and architectures and yeah. So let's start with the first question, why streams? What use cases would benefit from streams? Whoops. Oh, sorry. So remember the goal. We have high throughput, serverless, it's managed compute, and real time. So I highly recommend actually this talk, SRV304, that goes into sort of the differences between streaming and MapReduce. But here is sort of my take on it. For streams, you kind of have a data size constraint. Generally, it's sort of small amounts of data, and you also have a real time constraint. You need it to be available right away, and you probably don't need it a month from now, so you need to process it right away. You generally have access when you're processing to only a most recent time window of data. So this all kind of ties into the whole time constraint part of streams. Versus something like batch or MapReduce, you don't really have a size constraint. You can have really, really large sets of data, and there isn't that time constraint. You can take your time, processing large sets of data and generate a report, that type of thing. You have access to all your data when you do this processing as well. Whereas with streams, you only have that time window. And again, it's long running. So with stream processing, you have data that's being generated continuously, simultaneously, thousands of data sources, typically small sizes. You have your social medias, your IoT devices like farming equipment, stocks, click streams. On your website, you want to sort of know how users are using your web service, and sports analytics. I came from a sports gaming background, so I added that in there. All of this needs to be sort of processed sequentially, incrementally in sliding time windows. So Lambda. Real quick, it's your function. It's your code. And we give you a programming model so that you can easily, we'll run it for you. Flexible model, you choose your memory, allocate it. This is all the configurations that comes with the model that we give you. Really integrated security, like all the bells and whistles that comes with AWS, and it runs stateless. So this is kind of important as well. You don't have state. It's a container-backed system. This is the interesting part, because you defined your logic. Now, what are you going to do with it? You need it to be part of your overall architecture. So how do you trigger it? And this is where things get really interesting. Real quick, asynchronous push model. So there's three different flavors of this. So one is the asynchronous push model. You have your event sources that use the async invoke API that we provide. This is services like Amazon S3, Amazon SNS. They own the actual event, and they own delivering it to Lambda. So for Amazon S3, an example could be when you put something into a bucket, they own generating the metadata, the little bits of data that tell you what just happened, and they own giving it to Lambda, and then we have to do something with it. Synchronous push model, it's something like AWS IoT or API Gateway or Alexa. The difference here is they wait for the request back. And then we have the stream pool model. So this is the DynamoDB and the Kinesis Streams. In this case, DynamoDB owns generating the data and managing the stream itself and making it available for consumption. Amazon Kinesis, you own putting data into the stream, but Kinesis makes it highly available and available for consumption. Lambda is now responsible for pulling the data from these streams and making sure they get processed. So generally, this means grabbing data, keeping in memory, doing some processing, and then sending it to the actual Lambda function. It sounds really simple, but it's not really. So this is sort of what I'll be digging into further today. So again, just to summarize, Lambda can take in all sorts of events from a number of event sources, either from notification or for polling. And the key is you can process it however you like compared to other consuming event sources. And today we're going to concentrate on streaming events, in particular Amazon Kinesis. And with Kinesis, you can now open up to all sorts of real-time streaming data. So this includes financial data, IoT data, streaming log data is a really common use case, and IoT data. And we'll kind of also dig into sort of like use cases here. So what's Kinesis? Well, it's storage. It's real-time storage. So that means that the data is stored for a limited amount of time because you pretty much need it right away, and you probably don't need it a long time from now. It needs to be made available really quickly. So this is important because of the real-time constraint. Typically, it's less than a second from the put to get delay. It's a managed service. You have a framework. It's kind of like the compute model that Lambda has. Kinesis has its own set of APIs and how they define you should consume it and best practices there. And uses a checkpoint model in order to support multiple concurrent in-ordered processing. And this is sort of important because it kind of ties into sort of you're given a model in which to consume this stream, but there are definitely caveats and tricks on how to do this in a distributed, resilient, and scalable way. So how do you process a stream? In summary, you need to pull for the work. You need to call get records, and you need to grab that data. You need to have a checkpoint for progress, so you need a way to store that and update it. You can have separate checkpoints for multiple customers, so that's a really cool thing that Kinesis provides versus something like queues. And in general, Kinesis provides a KCL library for customers for a way to help you process the number of shards, distribute work, and kind of have that fault tolerance built in there. It's kind of a similar case for DynamoDB streams. The difference here is that DynamoDB owns producing the events as well. In this case, DynamoDB events, like if you update an item in the table, or if you put an item in the table, if you make changes. Otherwise, everything in the backend, they own the creation of the shards, and it is depending on the partition of your DynamoDB table, but they own distributing the records and across the partitions. So I don't know if I've convinced you, but it's hard. So how can you avoid using KCL and consuming this yourselves, having to keep track of the checkpoints and having to keep track of any fault tolerance? So we have some options here. One of them is Kinesis Firehose. So what Kinesis Firehose does is it manages the stream as well. So you don't need to worry about any shard configuration or partition key or also order. So if you need order, it doesn't do that for you. And it also manages the stream processing. So it pulls for records. It dumps it to one of Amazon S3, Amazon Redshift, or Amazon Elasticsearch. And I kind of threw this in there. It's not really that important right now. The compute power is the default of 8 KPUs. I just put that in there for comparison between the other two services, Analytics and Lambda. And this is cool. You can choose a Lambda function to transform the data here. There's some blueprints available on the Lambda console. Are you guys familiar with blueprints? So when you go on the Lambda console and you don't know where to start, when you go click Create Function, there is basically this repository of already created functions and configuration, basically like a wizard. And you can just click Create, and it'll create for you many different common scenarios, including transformation for Kinesis Firehose workflows from JSON CSV to whatever, or Apache log to JSON CSV. So that's Kinesis Firehose. This is kind of perfect for sort of ETL type jobs. So if you had data coming in, you need to transform and just dump it into storage, Firehose manages that for you in a really great way. Another classic example is dumping data like IoT events into S3. And then you can also connect Amazon Athena to the S3 bucket, and then it produces really nice graphs and stuff. So speaking of analytics, Kinesis also has a service called Analytics. It's their offering of a SQL language querying on top of real-time analyzed data. I consider this kind of like a filter or aggregation instead of a transformation that Firehose offers with their Lambda blueprints. So Kinesis Analytics doesn't manage the stream. You need to configure the stream itself. And then when you hook up Analytics to it, it manages the stream processing. So it pulls for records. It uses the SQL model to continuously map the record data to their internal concept of stream tables. This is aggregation. And then it continuously queries the internal stream tables for the desired results, and this can be your filtering logic. And then it outputs the desired results to additional stream tables, so further aggregation. And then eventually you can throw it into another Kinesis stream or Firehose. And it is a similar compute power of default 8 KPU. So this type of service is really good for real-time queried filtered analysis of data. Analytics gives you a SQL model. So if you're very familiar and you like the idea of SQL to do your filtering, it's a great way to sort of take advantage of that. You specify the mapping on your, you specify the mapping here between your source and your in-application input data. And you can also use S3 to sort of enrich the metadata that you want to use. And then you specify the query that you want to filter, and that's end up stored in intermediary updating tables, and all of this is happening in real time. It's just kind of aggregating. And eventually you output it to Kinesis or Firehose. So this kind of processing, especially based off of sliding windows, can be really good for most recent breakdown or average daily users type of deal, constantly changing with new incoming data. It's also really good for insights into latest trends. or changes in your system that help alert you to make relevant decisions faster, or combining of various different sources and kind of coming up with new data that's useful. A typical streaming architecture can consist of streams hooking into analytics, hooking back into streams, hooking into Lambda, and then throwing into DynamoDB. So there's, for example, social media. You can generate hashtags and do sort of constant aggregation in Kinesis Analytics. Throw the results into another Kinesis stream, and you use AWS Lambda to throw it into DynamoDB, since it's not available through Firehose directly. Lambda ends up being the bridge to anything. So Lambda. This is the last option, and what I'll dive into. Here, Lambda doesn't need to, you also don't configure the stream itself. You need to hook it up to a stream, but it manages the stream processing. So it pulls for records, we send it for invocation to a Lambda function, and the compute power here is I put it here for comparison, is your default limit. So your default concurrent limit is 1,000 times whatever you've configured your memory for your Lambda function and all the associated size CPU. You set it up with an API, create event source mapping. And the key here is now you can send it for invocation to a Lambda function. So really, your processing has opened up. And with Lambda, you get order. So we honor basically the contracts that Kinesis has set out. You have a soft concurrent limit of 1,000 invocations, but it's a soft limit, and you can ask for that to be increased, times a maximum of 3 gigabytes of memory and associated CPU. And it's completely customized model and functionality. So you're no longer restricted to very common but useful use cases like with Firehose or analytics. Your use cases really opens up here. Another kind of key difference is Lambda is available in every region. We're trying to go out with every new region. And currently, Amazon Kinesis Analytics is in 3, and Firehose is in 6, I believe. So it's something else to take into mind. So this is kind of what it looks like when Lambda processes streams. We have a service pulling data off of a stream, keeping track of checkpoints, and sending data off to Lambda for processing. As I hinted above, the 3 points aren't as simple as it seems. Otherwise, we probably wouldn't have to manage this for you. So we're going to dive into the details here and give you more insight into how Lambda does stream processing to help you appreciate both the awesome work that we do and also get a better sense of best practices when it comes to configuring and monitoring this kind of architecture. So configuring the event source, you have your batch size. This is the max number of records that could possibly be in one payload or one invocation to Kinesis. Not equivalent to how many records that we're going to be pulling off. We pull off as many records as possible. And the starting position just tells you which record that we're going to start processing from. So this is only relevant when you first create your event source mapping or when you disable and re-enable it. This allows you, for example, if you made a mistake, you need to turn off your function, disable it, and you do your fixes, and then you can re-enable it and start back off wherever you want to continue processing from. OK, so what are the steps? What's going on here? We have a stream of incoming data. It's like a sliding window of stored data. And then we have trim horizon here. Trim horizon is where Kinesis starts expiring records. The default age of records, or the TTL, I suppose, is 24 hours. So you have 24 hours to process your data. This is a soft limit. You can ask for Kinesis to increase this number as well. You also have your latest record. This is the most recent record that you just put into your stream. These are the 2 options that you can tell Lambda to start processing from. If you choose latest, you're basically saying, I don't care about anything that came before me. I'm just going to start processing from this point on. So Lambda is going to have a checkpoint somewhere here between latest and trim horizon. And we store this checkpoint in storage. the checkpoints continues and you make progress. And you can have multiple checkpoints. So you can have multiple consumers from the stream, and they all keep track of their own checkpoints or iterators. Here's an example payload from Kinesis. So the data actually is here. It's base64 encoded. But otherwise, you get metadata like partition key, the sequence number, and other metadata, the region. Oh, another key thing to note is that this is a batch of records, so you can tell that this is an array here. Here's an example Lambda function that would be processing from Kinesis. You have your event. This could be called anything, and you can get your list or array of records here. And for each record, here I've decided to you have to base64 decode it. In my case, I used an example that was in JSON format, but it doesn't need to be. It could just be any text. And I decided to upload it to a DynamoDB table. And I generally like to use game references. So in this case, it was a player and a score. So what's going on really behind the scenes? I'm going to go into the details of what we do per shard, and what happens per shard can happen in parallel for all the shards. So per shard, Lambda will call get record, and we'll try to get as many records as we can, with the max limit from Kinesis, which is 10K records or 10 megabytes of data, or whatever the batch size that you've configured for this event source mapping. So we call get records. If we don't get any record, then we're going to wait some time. Right now for Kinesis, it's 1 second. Otherwise, we sub-batch in memory. So we have all these records in memory, and now we've got to honor your configured batch size, the max payload that you can send to Lambda. And then so we construct this intermediary payload, and then we invoke Lambda synchronously with this payload. And this is key synchronously because we can't move on to the next batch of records until this current batch of records has completed. This is in order to honor the Kinesis contract of in-ordered processing. And then once you invoke Lambda, Lambda itself can send to multiple different destinations or any sort of transmotion you like. So Lambda blocks unordered processing for each individual shard. What this means is that increasing number of shards is your way of increasing the throughput or the concurrency available to your stream. This is also caveat. You need to be able to deliver data distributedly across your shards, because if you have 100 shards and you're only writing to one of them, it's not going to help you. So it's important to pick your partition key there. There's lots of best practices on how to produce data to your Kinesis stream, and best practices there that I won't go into today. But yeah, basically make sure that you're taking advantage of all the shards in your stream. Batch size may impact duration if the Lambda function takes longer to process more records. So this really depends on if you're sequentially processing, or if you're doing things in parallel, then you might be compute constrained or memory constrained. So you might think just increasing the batch size might increase throughput or make things happen faster. But if the ultimate duration of your Lambda function takes longer, then it's not going to really help you that much, since we are synchronously blocking per batch. We pull and block synchronously per shard. It's important to watch out if the put or ingestion rate is greater than the theoretical throughput, then your processing is at risk of falling behind. And what this means is that your record might be getting closer to trim horizon before we can process it. And once it hits trim horizon, then Kinesis is going to get rid of it. So maximum theoretical throughput here, it could be the number of shards times the Kinesis limit on how much we can grab, or how much we can grab divided by the Lambda function duration, so how long it takes for your Lambda function to get back to us so we can get to the next record. The effective theoretical throughput would be also dependent on what you've configured for your batch size. To emphasize the impact of failures here, our retry logic is such that we will retry execution failures and throttles until the record is expired. Again, this is to honor the in-ordered processing, the ordered contract that we have. So any throttles and errors are definitely going to impact the throughput of your processing. It's basically going to halt it. So the best practice is, we exponentially back off, but also alarm on any throttles or errors that your Lambda function might have, as well as any Kinesis throttles. Because even though you can have multiple consumers from the Kinesis stream, anything that consumes from Kinesis will be limited by certain APIs on the Kinesis itself. For example, describe streams or other limits. So definitely watch out for any throttling happening on the Kinesis side. And to sort of emphasize this, the effective theoretical throughput with retries is now the number of shards times batch size divided by not just the function duration, but how many times we have to retry that function. So I can go into some more examples here of different architectures. Or I was thinking, yeah, I'll quickly go through this, but I was also curious to hear if you guys had your own architectures and any questions there, because I thought that was a really cool format from the Chop Chalks. And also, if I had time, I could go into a quick demo. I just sort of spun up on getting a Twitter stream set up and having that put stuff into a Kinesis stream and having a Lambda process it. But some examples, using streams in Lambda is really good for real-time ad serving. You have, audience tracking system, ad exchange listeners, bidders, all sending data to a stream, which then can store and expose data for Lambda to do whatever business logic that you wanted into it. And then you can throw that into Firehose if you don't care about order, to really quickly throw that into S3 or Redshift. And I kind of think of this as sort of the assembly line approach, where kind of every step of the way you do another transformation and you add more metadata. We also have kind of the use case for anomaly detection. So analytics, say, will take a 10-second tumbling window of hashtag count from Kinesis streams, and we'll get the latest count of hashtags, send that into Kinesis stream, the results to Kinesis stream, or Lambda can then send it to any data store, or for further analysis, maybe to S3, which can then be surfaced visually or graphically. You can also send it to something like SNS for early detection. This will help you basically be aware of trends or things that are happening so you can react faster to your business requirements. And I kind of like to think of this, it doesn't always have to be a bad trend. It could be a good trend. You could be detecting something good that's happening, so it helps you react faster and take advantage of it for your customers and opportunities. Also, game analytics. I don't know how common this is, but I just threw that in there because that's what I used for a demo that I used. So I set up something, a Kinesis stream that was connected to a Lambda, which that did some processing, threw it into DynamoDB, had a list of, say, players and scores. You can hook up the Amazon DynamoDB to streams. You can turn that on, and DynamoDB streams streams all that data to another Lambda that does aggregation. So say you want leaderboards, like who are the top players at that given moment. And you can surface that through, throw that into an S3 bucket and surface it through CloudFront or a lot of different ways. So having real-time analytics brings a lot of stake and dimension to a lot of businesses. That's why I use this example. It's built on user interaction. So having, basically showing users a visual representation or something in response to what they're doing is really good motivation and captures progress, for example, or social competitiveness. So kind of wanted to open this up to questions, because I feel like then we can dive into the nitty-gritty of if anybody has their use case. Okay, so the question was best practices on throwing things into Kinesis, especially through API gateway. Yeah, generally, I guess it's the limits are per shard. So I guess it depends on, I guess it's unfortunate if you have bursty traffic and it's unpredictable. Generally, they try to increase shards if you think the throughput's going to be high. Otherwise, you do kind of need your own sort of batching or buffering in front of Kinesis if you don't want to hit those throttles, or if you don't want to do your own retry logic. That's sort of the advantage of some of the other managed stream services like Firehose, because they manage, increase the elastic sharding of it. If you have your own Kinesis, there's, I think it's there's blogs and best practices. I don't know if I have the best advice on how to produce data to Kinesis, but yeah. Okay, so the question was what are some best practices around error handling and detection, I guess, and having when your batch fails. I know something that customers a lot of times ask is, on the retry logic, having more ability to tune it. So that's definitely something we're aware of and working on. In terms of trying not to be redundant, that's a little bit tough because you're going to have to keep state on where you have processed, where something has already been processed and you don't want to do it again, and keep item potency. I guess when it comes to streams and say for asynchronous and somebody else manages the retry logic for you, it's sort of just part of the service where you have to be item potent. You can definitely log where you are in your in the Lambda function itself to help you sort of tell where you've done before. So if you need to reprocess, you can avoid records that you've already processed, or give yourself some flag. Lambda also has environment variables that you might be able to take advantage of, to sort of pass along metadata if you sort of are aware outside of the system how processing is doing. So those are some options you might want to look into. Yes, over there. Is there a way to maintain order within shards?
No, within shards. If I've done shards.
So you can sort of define your own order. I guess, it's not going to be the order in which the Lambda function itself is executed or when it gets to the container. But you could potentially, again, keep track of metadata outside of the architecture. And if you're checkpointing against DynamoDB, then you sort of might have expectations of where you should be and ignore data or sort of work around it that way. Again, you sort of have to write into your code the ability to be idempotent or to that sort of way. But the Lambdas themselves won't be able to get the batches in order. You will just have to decide business logic-wise what you do with the data when you get it in order to preserve extra order. Does that make sense? Okay, I think you were next.
We use Kinesis Analytics to process about 500 million records.
Nice.
And we have a constraint that the whole processing has to happen within 2 seconds. The time it goes into the stream to after Lambda's processed it, it's on the other data store. And that's been a real challenge. Sometimes that we get hit hard just network latency. The actual business logic of the Lambda is pretty quick. It happens in like 20 milliseconds or so. But if, for whatever reason, it takes a tiny bit too long to process, it just kills everything. So if you have advice, well, we tried Fanout, and the issue with Fanout is that the time just to call under Lambda is too long. That network latency kills. So I don't know if you have any advice on how to make it faster. We're getting around 1.5 seconds, and we're trying to get our Lambda iteration down, but it's still a little bit higher than that. We meet our requirement, but we can't do it.
Okay, so the question was around if I got this right, the latency between when you put a record into the stream and when it gets processed. So yeah, Fanout's not going to help there in this case because this is all internal to our Polar architecture. That's definitely something we are aware of. This is kind of like the compromise that you have between, we're doing this polling for you, so when you have no activity, in order to have better utilization, we can't just constantly be polling. That's sort of one constraint that we have. But we are definitely looking at ways to optimize this. Like right now, it's 1 second, and there's a lot of knobs and tunes that we're trying to optimize, but definitely something we're aware of. Getting that latency between when you put the record into the stream and when Lambda executes is, on our mind, I think.
How about the cost comparison between this and High-Throughput, having a dedicated system?
Sorry, can you repeat that question?
How about the cost comparison?
Oh.
Comparison between Lambda and a dedicated system?
Okay. The cost comparison between Lambda and a dedicated polling, a system to pull records from a stream or consume?
When it's a High-Throughput.
Okay. I would say the cost is really great because you're not really paying for us to do this for you. You're paying for Lambda to run the function, versus if you have an EC2 instance probably doing the polling, you're paying for the EC2 instance. Does that sort of answer the question? You're not paying for the polling, if that was the question, yeah. Okay, I think someone in the back was first, but I can't see. Yeah, so I got the last part, allocated versus used memory. That isn't impacted to you. Like many other AWS services, you pay for what you use. So even if you've configured a large amount, if you use a smaller amount, if you only use 10 seconds and your timeout is 3 minutes, you won't be charged for 3 minutes or anything like that. And then I think what was your first question again? Oh, okay, so I think you're talking about container reuse. So you have all these partitions. Really what a shard guarantees for you is that everything in that shard is going to be ordered. That's all it does. For example, if you wanted all of one account's data to be processed in order, you would shard it all you would have the partition key or hash it to the same shard. It doesn't guarantee that it's all going to go to the same container. So as soon as we do the synchronous invoke to Lambda, all of that is subject to Lambda's backend internal sort of container reuse lifecycle. I don't know are you familiar with the lifecycle of? Okay, so just real quick, there's the concept of warm and cold containers. When it's a new invocation and you haven't had one for a while, you don't have a warm one, we're going to spin up a new container, and that's going to have its initialization costs. If it's a warm container, it might have some of the same resources that a previous invocation had. So you do save a lot of initialization. All of that is sort of like our proprietary logic and orchestration logic. So you don't have insight into that, and it's not guaranteed. We are trying to optimize that in the backend ourselves as much as we can. And we're constantly improving that. But there's no guarantee that in the same shard that you will always go to the same container. Cool. Yeah? So in general, like, yeah, we try to warn if you have really tight latency constraints, try not to have, and this might be tough, but try not to have super sparse data or super sparse traffic. Again, this is all sort of like to do with how warm things are and how, and like how we're trying to mitigate against utilization. So, you know, if there's a way for you to control like when the records are inserted, or have some sort of buffer. I guess this kind of goes into like what are best practices for inserting data into the Kinesis stream again. Yeah, it might be useful to, you know, have some sort of buffer in front of it to try to like have it be more spread even in that case, if you're very, very latent sensitive. I think you have first.
So this is it almost falls into the earlier question about the fanning out not being performant. We actually don't have that issue. We are processing around 400 million records, and we have to fan out because each individual execution takes too long. Otherwise, our piece of string backs up. We don't care about order. I mean, that can never be an option. Just push a button and just say invoke asynchronously because that would help us a lot. Because right now we're writing our own logic. We're actually running into an issue where apparently there's a Lambda burst limit that you know, we're just blowing away the number of Lambdas that we can invoke at any given time and getting errors throughout the entire run.
No, that's a fair point. Yeah, fan out, if it means that you've reduced the duration of your Lambda function, will definitely help throughput. So yes, if you have like, you know, a fan out function that's like, you know, very short and then it hits off other Lambda functions that's longer duration, that will definitely help. Whether if we will ever have do that for you, I think was the question. I'm not going to say no, also I can't make promises, but we're definitely aware of the issue. So yeah, something definitely in our minds. I think somewhere in the front you had a question.
I did, but my question was very similar to his, which was essentially what kind of solution you have available when you need the kind of performance that Kinesis provides and some of the like dynamic scale that Firehose provides, but you're not necessarily pushing to one of the three options for Firehose. Like you'd like to be using Firehose, but then pushing directly to Kinesis.
Yeah.
You don't want the extra latency of like waiting for S3 events by pushing Kinesis to S3.
Yeah. No, I think we're aware of the issue, and I think it's, you know, yeah, there's a path forward there. Yeah. Sorry, I think over there.
So for each single shard, how many consumers you can attach to it before it hit the throughput limit?
Okay, so the question is how many consumers can you attach to a single shard before you start getting throttled? I think the control plane limit for a shard is like 5 per second. I don't know if anybody else remembers. So it's not sort of like how many consumers, it's how often. If you have like, you know, 10 consumers and they only call pull every 20 minutes, like maybe it'll be okay. I made those numbers up. But if you have like 2 and they're constantly pulling, then they're going to get throttled.
Right. Well, what if I have 10 different downstreams and 10 different consumers that are constantly pulling lots of records out from the pieces? What would be the solution? Just go now or something?
Yeah, so I mean, definitely, I think there's a lot of, we hear a lot of customers asking for this because it's like a really great option to have multiple consumers from the same stream. You have like a, you know, source of truth or a data that lots of people can sort of take advantage of, except for this limit. So it's definitely on our radar and Kinesis' radar. There are some architectures like kind of around it, like you can fan out the Kinesis itself, like you, for example, have a Kinesis stream that basically just fans out to multiple other streams, and it's just a replication of the data, but it makes it available for more consumers to read from. So we've definitely had, there might be blog posts on that, but we have customers doing that. But on the other case, it is something we're definitely aware of and also trying to improve that experience for sure.
I got another question.
Oh. Okay. Is it real quick?
So earlier you mentioned about the retry in the batch error on the Lambda function. So the retry is actually invoked by the Kinesis or by the Lambda calling function.
Lambda is from on the consumer side. So any retries is owned by whatever the managed service is that's consuming it. In this case, Lambda owns that.
So when you say fail on retry, it's basically it's the code fail. So if Kinesis invoke the Lambda function, Kinesis will say, okay, you took the batch, it's good.
So Kinesis doesn't invoke anything. Kinesis just makes data available for consumption. Yeah. Lambda grabs data, does some in-memory processing, throws it for synchronous invocation. If there's any failures or throttles, Lambda retries. Cool. Thank you.
I just wanted to check a couple of implementations. So on the concurrency thing, you said Lambda holds 1 second, so that would essentially be one of your 5 consumers. I guess that's
Yeah, that's on empty. So if we got records and we didn't get any records back, we'll wait 1 second and try again. So.
with the concurrency, you mentioned that synchronous Lambda invocation from Kinesis doesn't provide all the same guarantees. Does it still preserve the non-concurrency that is only one Lambda will be processing records from a shard at a time?
Sorry, I didn't understand that question.
So, for say you have a stream that's got 3 shards, and you've got Lambda consuming it.
Right.
You never have more than 3 Lambdas running into one shard, right?
Yes, that is correct. If you have a 3-shard stream and Lambda is consuming from it, you wouldn't have more than 3 concurrent Lambda executions running at the same time. No, you would never have 2 Lambdas consuming from the same shard. Yeah. Okay, I think yes.
Could you shed some light on Iterator Age metric?
Yeah. Yes.
How that's computed, especially like sports streams, sometimes it's weird. Weird getting you to find new parts of like based on the dynamics.
Yeah, so you get the Iterator Age. So the question was kind of more insight into how the Iterator Age is computed on the Lambda side. You get 2 Iterator Age metrics, one from Kinesis, one from Lambda. As far as Kinesis view is, it's the average or the aggregated across all the consumers for that stream. As far as Lambda is concerned, it's any stream that's hooked up to that Lambda. So if you have multiple streams hooked up to that Lambda, the data might also get kind of weird. So if it's bars, I mean, the way that we calculate it is the last record that each shard saw would be 1 data point. And then so when you select, max or min or average, it is using those data points to create it. And there's some discrepancies that you might see between shards might be, if you have differences, a specific customer, if you're, for example, partitioning to a certain shard, might be having trouble versus the type of data that's going to another shard. And so one particular shard might be actually having more trouble than another based off of the data that's going to it and how Lambda is reacting to it if it's getting errors specifically. Oh, yeah. So, are there any more questions? Yeah. Oh. So do analytics?
Let's say you have some data coming in from the people training in Las Vegas, and then you need to Comcast or whatever the local provider is. And you have that information, and then there's people running in San Francisco. You're getting all that data going through. The answer you gave before was each Lambda function kind of
So in this case, I had a really simple sort of design here. The AWS Lambda was kind of just dumping into DynamoDB, so I wasn't doing pre-aggregation at that point. I could see, so I think the question was a concern on like if you're doing aggregation at different stages, sort of how that manifests in the end result. Definitely that's a concern. You have to really think about what you're trying to convey. In my case, I kind of just had Lambda throwing player and a score into DynamoDB, just a log, and then my second Lambda function was the one actually doing all the aggregation. Yeah, so some really, really good stuff to batch is sums, because it wouldn't matter at what point in the process you did the sum. So if you're just looking for top or max, then you can just do sums in the first Lambda, go into Dynamo, do another sum in the second Lambda, and then you would get the same end result type. So a Lambda function is your code, and you can do whatever you like with it. So if you want to. Oh, does a Lambda consume from DynamoDB, or is there another? I'm not really sure. I know there's, you might want to check out something like AWS Glue for different ETL workflows, or they kind of go more into how you can have a managed scheduled query against your storage. So maybe take a look at AWS Glue for that. And then, oh, sorry, I was gonna. Here. So real quick, I just wanted to show example data. So in general, oops. I'm going to try to make this bigger. Okay, I don't know if you can see this, but kind of in general, when you put a record, it just looks like this. You throw data in. I did a command, so I can only look at it from here. I set up a Twitter stream this morning where you can basically get a random sample of sample of tweets. This is sort of what it looks like. Don't look at my secret keys. But I mean, it just looks like this. I don't know if you can see that. I can't even see it. But it's just statuses, sample.json. You do a query, you get back like a dump of data. And I can show you quickly what that looks like. Oh, here we go. So it kind of looks like this. This is the response that you get. You just get every line is a dump of random tweets. In particular, I'm interested in the CSV, the column that says text, because that's the actual text. I'm not responsible for any of this content, so I don't know what it actually says. And so, yeah, when you call this API, you open up a stream. It's constantly dumping data. And I just kind of did this to try it, but I try to pipe it into something that could send data to into a Kinesis stream. So again, ignore all the keys. I'm going to destroy all this later. But in this case, I just curl this. This API is just a get on statuses sample. And you'll just constantly grab a bunch of data, and I did some janky grepping and stuff to get just the text that I want, and throw it into a stream. I called it demo. And I can show you sort of like what the end result looks like on the Lambda side. Man, this whole screen thing is confusing. Okay, I'm going to try to close this and restart it. Oops, so here's the console. Is it disappearing? So here's sort of the console, and you can go into the monitoring tab and take a look at your invocation errors. And here we have Iterator Age on where the last record and how old it was. Whoops. You can go also directly into CloudWatch logs and like dig into sort of the metrics over there. You can add alarms, CloudWatch alarms on any errors or throttles that you see. You can also go into CloudWatch logs to see any the actual error outputs. So this is what the CloudWatch sort of log stream looks like. And here I'm dumping out the actual payload and the resulting, yeah, so, okay, let me see that. So if you have any errors, this will be like, you can also set different watches on the CloudWatch logs and definitely monitor this for any insight into the details of your stream processing. And the result is we're dumping data into DynamoDB. So this is sort of what it ends up looking like. You have a random player ID in the score, and I just grabbed random tweets and threw that in there. I don't know if there was like a question specifically on a type of monitoring for logs. Yes?
You're basically pulling in data from Twitter, just random tweets. Creating a stream in for Kinesis is per row, basically.
Yeah. Yeah, and when you create your Lambda function, you can go into these triggers to sort of, this is on the console where you can visually set up the trigger. Here I have the Kinesis demo stream, but if you wanted to add another one, you can do so. Oh, geez. You can choose from various different sources. And I'll try to find stream. Kinesis again. And this is where you set up the configuration like batch size or the role and the starting position and stuff like that. Yep. Yeah, another important thing to note, when you set up the stream, I mean, you'll hit this right away, is making sure that your IAM role has the right permissions to read from your stream and also to describe stream. So all of this is in managed roles. When you go into IAM and you create a role, you can look at the managed policies and type in Kinesis, and it'll pop up with a role that's probably best for your use. Yes?
We had an application where we wanted to get back to data in lots of more complex applications on it using external library like Pandas and Numpad. We started packaging that zip upload to Panda, getting very, very large. So I want to
Oh, sorry, was the question a very large Lambda function?
Well, yeah, basically is that we're getting very large because of dependencies on things like NumPy.
Okay, so if you're having trouble with very large Lambda zips, there is something that might help you. Watch out for it on Thursday. Okay. Yeah.
Actually, I was going to ask a simple question in regards to really, one thing that
Yeah.
it does is be able to build an IAM that would be, not IAM, sorry, an AMI that would be used as the base for our Lambdas deploy. It's just because, we use Python too for some of our Lambdas, and some of the data scientists rely on packages that are also rely on shared libraries. It would be much easier just to bake it into the OS and then us deploy our Lambda package on top of that. And then deploy.
Yeah, it's definitely a constant battle. Like, what do we include? What do we support forever, maybe? Versus like the flexibility that we give for customers and more the guarantees that we're never going to break customers depending, because all of these libraries and packages are constantly updating, right? So, yeah, but that's an interesting point. Yeah, I think I'm done here, or like the time looks over. So thank you. That's my Twitter handle. I don't use it for that much, but mostly complaining on airlines. And thank you. And don't forget to fill out the survey.